Hi, and welcome back to 2.1, the lesson where we're talking about the derivative and the tangent line problem. And this is part 2. So we're now going to start talking about derivatives. So something you need to know about the derivative of a function is the rate of change, also known as the slope, of the line tangent to the function. A more formal definition of the derivative of a function is as follows. The derivative of f at x is found when we go and we take what we're going to denote as f prime of x, and that's going to be equal to the limit of f of x plus h minus f of x all over h as h approaches 0. Provided the limit exists for all x for which this limit exists, f prime is a function of x. And f prime is just another way we say the derivative. So there are a few different notations that we use to represent derivatives. Those notations are f prime of x. Sometimes we just use y prime. We can go dy over dx ddx of f of x. And this last one isn't one that I've really used too often. We have this capital D, the little x, and y. So really, the important part of understanding what the derivative is we're going to utilize that difference quotient that we were using to find the slope of tangent lines in our last two examples from our last video. So now let's look at another example. We'll call this example 3, and we're going to have to find the derivative f prime of x when f of x is equal to x cubed plus 2x. And we're going to use that limit process. So what we're going to do is we're going to say f prime of x is equal to the limit of, we'll do f of x plus h. So wherever we have an x, we're going to go and put an x plus h in for it. So x plus h quantity cubed plus 2 times x plus h minus f of x. So minus x cubed plus 2x. We're going to put all of that over h, and we're going to let h go to 0. Now, instead of actually writing x plus h times x plus h times x plus h, I did give you a handout in class on little algebra cheat sheets. So x plus h quantity cubed, it actually expands to the following. So we're going to rewrite in our new line the limit of, so x plus h expands to x cubed plus 3x squared h plus 3xh squared plus h cubed, and then let's also distribute our 2 to that x plus h. So 2x plus 2h. And while we're at it, let's just distribute this minus to the x cubed minus 2x. So we're going to have a minus x cubed minus 2x. And that's all over h. And we do this as h approaches 0. So let's look in the numerator and see what all do we have that might be able to cancel out. I do see we have an x cubed and a minus x cubed, so let's cancel them out. I also see we have a 2x and a minus 2x, so they can cancel each other out. And then every other term we're left with in our numerator has an h, and our denominator has an h, so we can cancel one of those h's in each term. So what we're looking at now is finding the limit of 3x squared plus 3xh plus h squared plus 2 as h goes to 0. And if we use direct substitution at this point and put 0 in for h, we're going to find that our limit is equal to 3x squared plus 3x times 0 is 0, it's gone. 0 squared is 0, it's gone. So we have just this plus 2 at the end. So our derivative is simply just 3x squared plus 2. Some of us might be lost, and that's okay. Let's look at another example of how this definition of a derivative works. So example 4. We're going to find f prime of x when f of x is equal to the square root of x. And then this question, we're going to add a little bit more to it. We want to find m, or find the slope, at the points 1, 1, and 4, 2. So first we need to go through our limit process to figure out what is the derivative of this problem. So we have the limit of the square root of x plus h minus the square root of x all over h as h goes to 0. Now, to find this limit, in our last chapter we talked about the process of rationalizing what we have here. So we're going to multiply the numerator and the denominator by the same thing. We're going to multiply by x plus h, the square root of that, plus the square root of x over the square root of x plus h plus the square root of x. What that's going to do is in our numerator, because now we have a difference of squares that we're multiplying, we're just going to have the first term, the square root of x plus h, we're going to square that. So we're going to be left with just an x plus h minus, we're going to square the square root of x, so we're just going to have x, and that's going to be over h times the square root of x plus h plus the square root of x as h goes to 0. So let's clean this up. Let's look for things we can cancel out. In our numerator we have a positive x and a minus x. They're gone. And in our numerator and denominator we have an h. So we can rewrite this as the limit of 1 over the square root of x plus h plus the square root of x as h goes to 0. And if we put 0 in for h, what we'll have is 1 over the square root of x plus the square root of x, which we can simplify and make 1 over 2 square roots of x. So our derivative is 1 over 2 square roots of x. That's what f prime of x will equal. We're not quite done with the problem. They did ask us to find the slope of the derivative at 1, 1 and 4, 2. So I'm going to clean up my screen here while I do that, or get ready for that next part. Okay, so our derivative was 1 over 2 square roots of x. So we're looking for f prime at 1 and then f prime at 4. So at 1 we're going to have 1 over 2 square roots of 1. The square root of 1 is 1. So we just have a half. At 4 we're going to have 1 over 2 square roots of 4, and we know the square root of 4 is 2, so we've got 1 over 2 times 2, which means the slope at that point is going to be 1/4. So, to recap, we found our derivative was 1 over 2 square roots of x, and the slope of that line at the point 1, 1 was 1/2, and the slope at the point 4, 2 was 1/4. I think we have enough time for one more example in this video, so let's do that. So this is example 5. We're going to find dy over dt, which we really just say dy dt, for y equals 2 over t. So that really just means we're finding the derivative of the function y equals 2 over t. So let's do that. We're going to have to use our limit process. The limit of, we're going to have 2 over t plus h minus 2 over t. In fact, I'm going to get rid of those parentheses because I really don't need them. Then we're going to put all of that over h. I'm going to say h approaches 0. So in our numerator, we can't really subtract those quite yet. They are two fractions. We did learn a long time ago in our math careers how to subtract two fractions. In fact, two rational expressions are what these are. What we can do is we can multiply this second one by t plus h over t plus h, and we'll multiply this first one by just t. If we multiply each one by the other one's denominator, we've then got a common denominator. So we can rewrite this as the limit of 2t plus, not plus, minus 2 times t plus h all over t times t plus h all over h as h goes to 0. And I even think, let's clean that numerator up a little bit more. Let's distribute this 2 to the t plus h. And we're going to have the limit of 2t minus 2t plus h, 2h, excuse me, over t times t plus h all over h as h goes to 0. In fact, if we distribute the minus sign, we can get rid of the parentheses right now. So let's just do that. We'll get rid of our parentheses and we'll make this plus a minus. Now, there's also something we learned a long time ago in our math careers, that we don't like dividing fractions or rational expressions by other rational expressions. So what we can do to get rid of that h that we're dividing everything by, if we multiply everything by 1 over h, that's going to get rid of the h in our denominator. And what we're going to be left with is going to be 2t. In fact, we can even cancel out our 2t's. So in our numerator, what's going to happen is we're going to have the limit, and the numerator will be negative 2h over th, or t times h, times t plus h as h goes to 0. And here, our numerator and denominator both have an h, so let's cancel those out. So we can rewrite this as the limit of negative 2 over t times t plus h as h goes to 0. And now if we solve this with direct substitution, the h in t plus h is just 0. So we're going to have negative 2 over t times t is t squared. So our derivative of 2 over t is negative 2 over t squared. We have a little bit more left in this lesson, but not enough time to get it into this video. So stay tuned. This lesson is going to have a third video to it.